the transit of Venus, and it happens when the Earth and the planet Venus line up perfectly in front of the Sun. The last time anybody saw a transit, Queen Victoria was on the throne, and the invention of television was still 40 years away. This time, television is going to help you to take part, and it should be really good fun. This is where you find out how to observe the transit of Venus safely and how to use it to calculate the distance to the Sun. Welcome to Stardate. As one of the observers said in 1882, to have seen even a part of a transit of Venus is an event to remember for a lifetime, and they're very rare, so don't miss it. It's dangerous to look at the Sun with the naked eye, but we'll be suggesting lots of other ways to view the transit safely. We'll be explaining what a transit is, how astronomers used them to measure the distance to the Sun, and why they're so rare. We'll tell some of the amazing stories from the only 5 transits ever seen by human eyes, including how this remarkable movie of the 1882 transit came to be made. We'll be explaining how you can join in some real science on Tuesday and help us to get a Stardate measurement of the distance to the Sun. And we've got an update on the very latest science, how transits can reveal planets orbiting distant stars, and could even be used to discover alien life. So, what exactly is going to happen on Tuesday? Well, most people think of Venus as being a planet that you see at night, either just after sunset or just before sunrise. In fact, it's up there all the time, but we can't see it because the sun's too bright. Today, it's just above the Sun and to the left. To see what's going to happen, we need to model the whole thing on a slightly smaller scale. So I've got some friends along from Stockwood Green Primary School, and they're showing how the whole thing works. Now, the great big orange ball in the middle is the Sun, and we've got just 2 planets going around it. There's Venus, the multicoloured one, close in, and Earth, further away. And in fact, because Venus is closer in, it goes around quicker. It goes around almost twice as fast as the Earth. So you can see Venus overtaking the Earth and then catching up again. Now, you might think that they'd line up very often, but in fact, the orbit of Venus is tilted. So if we're like this, the orbit of Venus is at a slant. And the result is it's only very occasionally they line up. In fact, twice every 122 years. And that's exactly what's going to happen on Tuesday morning. The next one is going to be in 2012, but it won't be any good trying to watch it in Europe because it's going to happen in the middle of the night. The one after that is in the year 2117. So I'm sure I won't be around. In fact, I don't think you'll be around either. Next Tuesday really is a once-in-a-lifetime chance. Now, there's one golden rule for observing the transit of Venus safely. What is it?
Don't look directly at the Sun!
It's no good looking directly at the Sun because it's so bright you'll never see a little black dot. And what's more, you can do yourself terrible damage. What will happen?
You'll go blind!
So observe the transit safely. And one of the simple ways to observe it safely is to watch BBC One. I'll be popping up throughout the morning with live images and reaction from all around the world. Then on Tuesday night, we've got an hour-long roundup of all the highlights from the day. If you want, of course, you can go out and join one of the events going on all over the country, like this one here at Castle Green in Bristol. You can find out a complete list of the events on our website, www.open2.net. And here's a little foretaste of what's on offer. First off, it's sunny Salford.
Hi, we're Salford Astronomical Society. We'll be somewhere out and about in the Manchester area. Anybody sees a telescope set up, come over, have a look, join in with the fun.
North of the border in Paisley, they'll be dressing the part at the Coates Observatory.
To view it, we use an instrument like this, which is a combination of lenses and mirrors, which safely projects the sun's image onto a piece of paper.
Even high-tech professionals will be joining the fun.
Here at Jodrell Bank Observatory, we'll have lots of telescopes to enable you to come and have a look at the transit yourself. There's also a link. This telescope was one of the first in the world to measure the precise distance of Venus by radar.
On the Isle of Wight, you can watch the transit from a grand charity party on Colonel Geoffrey Webber's lawn.
Next Tuesday, for the transit of Venus, we have set up a scale model of the solar system here at Shape Manor, Chiltern, Isle of Wight, and
The Vectis Astronomical Society are going to join forces and bring our telescopes so that the public can come in and view the event safely.
so come along and enjoy the fun in large numbers.
Right across Northern Ireland, astronomers, societies and schools will be joining forces to watch the transit. This one's St Patrick's Academy in Dungannon. The Wessex Astronomical Society will be all around the southwest coast.
We're here in Wimborne in Dorset. We are going to Poole Park, we're going to Bournemouth, we're going to Worthmere Travers on the Dorset coast, showing people this amazing event absolutely free of charge.
There'll be telescopes set up for the public outside the National Space Centre in Leicester. In Scarborough, 122 pigeons will be released, one for every year since the last transit. And in Whitby, there'll be telescopes in front of the replica of Captain Cook's ship, the Endeavour.
We'll be able to give you the opportunity to observe the transit in safety.
And I hope you're enjoying this stirring music. It is, of course, the Transit of Venus March, composed by John Philip Sousa to celebrate the 1882 transit. You can watch the transit from anywhere in Britain, even your own back garden. And this is my back garden. And this is Dr. Lucy Green, who's a solar astronomer with some very fetching sunglasses on.
Thank you very much, Adam. I've got a pair for you as well.
Good, excellent. I love these things. I can't see anything at all, apart from my own eyes, that is.
You won't be able to, I'm afraid, because these viewers, in fact, reflect most of the light and, more importantly, the heat from the sun and enable us to look directly at the sun safely. Normal sunglasses or even Polaroid glasses won't protect your eyes from the damaging heat and the light from the sun.
OK, so where do you get hold of these things?
You'll be able to get them at events happening on Tuesday. They'll be given out across the country.
Excellent. Now, you've got all sorts of bits and pieces of gear here. Could we have a look at them?
I have. Let's have a look.
Now, this looks like a giant loo roll.
It is. It's in fact the centre of a carpet, an old carpet
Oh, I
tube.
see.
But this is something that anybody can make at home, and it's a pinhole camera.
Ah! So the front's blocked off.
That's right. We've got some gaffer tape here and a piece of kitchen foil, and we've just pricked a pinhole in the end there.
Oh, that's lovely, because you can make a really tiny hole, nice clean hole.
That's right.
So we've got an image, we've got to point this at the sun. So down the end here, we've got a screen, which is just tracing paper or something like that,
That's
is it?
right. Tracing paper or baking roll or something like that. And the image of the sun falls on that piece of paper.
That's really simple.
So it's really good.
You would have to lie on your back on the grass to look at it.
It's not
wouldn't
very convenient.
it? Right, but cheap.
Very cheap.
OK, now here we've got binocs.
That's right.
And a teleaerial.
Absolutely. You want to cast the sun's light through one side of the binoculars.
OK.
So block off one side here, as we've done, and then we've attached it to this TV aerial so that you can move.
Ah! Oh, I
the
see.
position of the binoculars.
So it's a sort of complicated tripod.
That's right.
That's very neat. And the bit of cardboard?
That's right. That's so that when the image of the sun is projected through the binoculars, this card blocks the other sunlight, casts a shadow, so the image of the sun appears brighter.
OK. Now this looks like an expensive piece of kit. You have to buy this, yes?
You do. You can order it over the internet, and it's called a solar scope, but they're not expensive. They only cost about £40.
Oh, I see.
So
OK.
they're really accessible.
So explain to me how this works.
Right. Well, this is a kind of mini solar telescope, if you like, and the sun's light comes through this tube here, through the lens, falls on a mirror inside the box, and projects an image of the sun inside the box, which is about 3 inches across.
I do like that. I fancy one of these. Now you've got some clever stuff down here, haven't you?
I have.
Now, this just looks like an ordinary video camera.
That's because it is, Adam. It's just a
I
normal
spotted
video
something.
camera. And what we've put on the end is some filter which reflects most of the sun's light. And it's called Barder filter, which stops down the sun's light by about 100,000 times, in fact. So it's very, very easy to set up, but you must remember to put your exposure to manual and your focus to manual as well, because you don't want the camera trying to focus on the inside of the film here. You want it to see
The sun is quite a long way away.
That's
Yes,
right,
yes,
that's
okay.
right.
That's really good. It's about half filling the frame, isn't it? Fantastic. This, on the other hand, looks like a serious bit of equipment.
Well, you're very privileged. This is my own telescope here.
Oh, wonderful.
It's just a regular telescope,
Right.
but what I'm doing is putting a special filter on the end, which again cuts down the amount of sun's light entering our telescope.
Okay.
And the other point to do is to cover up your finder scope, because you don't want an image of the sun falling through your finder scope. It could burn your hand or some part of your skin that gets put in the way.
Okay. Well, on Tuesday, we're going to have a telescope very much like this in Egypt, where we can be fairly certain there aren't going to be clouds. We'll have a nice picture of the sun, and we'll have the pictures relayed back to us. And meanwhile, Lucy, you're going to be with me in Greenwich, is that
That's
right?
right.
Terrific. Is it going to be sunny? Let's hope so.
We hope so.
The first transit of Venus ever seen by human eyes was less than 400 years ago. Which is odd, isn't it? What happened to all the earlier ones? After all, they've been going on ever since the solar system was formed. Well, there are two reasons, really. The first is you need a telescope to see a transit of Venus, and the telescope wasn't invented until about 1600. And second, you need to know when to look. And in order to find that out, you need a good understanding of how the solar system works. The whole thing first came together one afternoon in 1639 in the little village of Much Hoole in Lancashire, as Vanessa Collingridge explains.
Jeremiah Horrocks was only 20 years old when he made his great discovery. It began when he realised that his observations didn't match the existing astronomical tables, the ones produced by two giants of astronomy, Johannes Kepler and Nicolaus Copernicus. When his amateur astronomer friend William Crabtree reported the same errors, he decided to recalculate the tables. A bit like a young student today rewriting one of Stephen Hawking's books. Horrocks lived in Much Hoole because he was employed as a tutor to the children of Carr House. It was while working on the tables in the autumn of the year 1639 that he spotted an astonishing conjunction. He realised that if he was right, a transit of Venus would happen on November the 24th, in about a month's time. The morning of Sunday, November the 24th, dawned with the wintry sun hidden behind clouds. Nevertheless, Jeremiah set up his telescope to project an image onto a carefully drawn chart, if the sun ever came out. He couldn't calculate accurately enough to predict exactly when the transit would start. In his later account, he wrote,
"I watched carefully on the 24th, from sunrise to 9 o'clock, then from a little before 10 until noon, and at 1 in the afternoon, being called away at intervals for business of the highest importance."
Jeremiah's business of the highest importance was attending church. He was a religious man and probably had a formal role in the services. But he knew he might be missing his only chance to view the transit. It was almost as if the sun was teasing him, coming out while he was in church and disappearing again when he got home. Finally, at about 3:15, the sky cleared.
I beheld a most agreeable spectacle, a spot of unusual magnitude, and of a perfectly circular shape, which had already fully entered on the sun's disk. Not doubting that this was really the shadow of a planet, I immediately applied myself to observe it.
The telescope projected a reversed image, but before the sun finally set, half an hour later, Jeremiah Horrocks managed to make 3 distinct observations of times and positions. The most unexpected thing for Jeremiah was how small the dot of Venus was, and therefore how large the sun must really be. Jeremiah's friend William Crabtree was the only other person to see it, but he was so overcome with emotion that he failed to make any measurements. Jeremiah Horrocks' story doesn't end happily. He died a year later, at the age of just 21. His name isn't well known outside astronomy, but churchgoers in Muchhool have a constant reminder of his great achievement.
So why were those early astronomers so excited by the transit of Venus? Well, what they wanted to do was to measure the distance between the Earth and the Sun. That was a sort of holy grail. Once they had that distance, they could measure all the other distances in the universe. And the basic principle was triangulation. Lucy, could I borrow you for a minute? Hold out your arm like that so we form a baseline. Okay, now the Sun is that great silver ball. If you point with your other arm at that, then we can measure the angles between our arms, just this angle here, all right, which is about 80 degrees. We form a triangle, and the angle between our arms changes depending on how far away the Sun is. And here's the clever bit. If you know the length of the baseline and the angles, you can work out how far away is the thing you're pointing at. That's the theory, anyway. The problem with measuring the real Sun is that it's tens of millions of miles away. Because our baseline is so short in comparison, we both end up pointing more or less straight ahead, and it's impossible to get an accurate reading of the angles. Now, you might think the answer is to increase the distance between us, but the Sun is so far away that we could be standing on different continents, and we still wouldn't be able to measure the angles with the precision we need. But if you can actually use Venus as a piece of apparatus, you can do it much more accurately. Now, here is Venus. When it transits, it comes like this across the face of the Sun, all right, quite slowly. And all you need to do is to measure the times, the time when it comes onto the edge of the Sun and the time when it leaves again, and then from those times you can work out your angles, and from the angles you can work out your distance, and then you've cracked it.
The distance to the Sun was crucial. With it, astronomers could work out all sorts of other things, like the scale of the solar system, the mass of the Sun, and even the distance to other stars. All they needed were the timings of a transit recorded from different places. So when the next pair came along in the age of sail, astronomers were shipped all over the world to observe it.
In 1761, the two most powerful nations on Earth, Britain and France, were at war.
Despite the danger, hundreds of astronomers set sail for distant lands to measure the transit. Every one of them had a story to tell, but my favourite is that of the Frenchman Le Gentil de la Galisière. He set sail for the Bay of Bengal a full year before the transit, but found that his planned observing point had been taken by the British. Worse, a French fleet sent to liberate it had been sunk on a coral reef. He sailed further down the coast, but the British had been at it again, and eventually he had to turn around and head for Mauritius.
Unfortunately, time had run out for Le Gentil. He didn't make it to dry land in time and had to watch the transit from the swaying deck of his ship, unable to make any scientific measurements at all.
He waited 8 years in Mauritius for the next transit, but on the day it was too cloudy and he missed that one too.
He suffered 2 shipwrecks on the way home, and when he finally arrived in Paris, he found that his family had given him up for dead and sold off all his possessions.
The main aim of all the expeditions was to measure the exact time that Venus appeared to pass completely into the disk of the Sun.
Timing this moment was crucial to their calculations, but something entirely unexpected happened. Instead of passing cleanly into the disk of the Sun, a strange optical effect made it look like Venus was clinging to the inside edge, like a drop of water falling slowly from a tap.
120 astronomers measured the transit, but this black drop effect meant that they couldn't agree on their timings. Calculations for the distance to the Sun varied wildly, from 77 to 97 million miles.
The 1761 transit had been a disaster. But with another one just 8 years away, there was a second chance for scientists to get it right.
For the second transit of the 18th century, the British Royal Society enlisted the help of master navigator Captain James Cook. He was sent to Tahiti in the South Pacific, where he built a heavily guarded observatory called Fort Venus. He managed to take a number of important measurements, but as you can see from his notes, he still suffered from the black drop effect. After the transit, Cook's orders were to set sail and survey the great southern continent, work that was to extend the limits of the known world and make him a household name. But he was just one of many heroes who risked their lives that year, trying to calculate the distance to the Sun.
More than 100 expeditions reported back with figures for the transit of Venus. And within a couple of years, they worked out a figure for the Earth-Sun distance of 95 million miles, which was a little bit more than we think now, but not bad. Well, we're going to follow in the footsteps of those 18th century astronomers. We're going to work out our own distance from the Earth to the Sun. And I've got with me here Andy Norton from the Open University, who's going to explain how we're going to do it.
What we're going to ask our viewers to do is measure the time at which the transit of Venus is just about to finish, when the planet Venus is just moving off the surface of the Sun. We want people to measure that time. It's the so-called third contact point.
OK, now how accurately do we need to measure it?
Well, to the nearest second, but that's the important thing, you see, because
Wow.
it's very difficult to measure this. Venus moves very slowly across the Sun. It takes about 6 hours for the whole transit. So judging exactly when that final moment happens is going to be very, very difficult.
So, all right, what everyone has to do is to presumably watch the telly is the best way of doing this.
They can take measurements off the television, off the website, or from their own measurements by projecting the image. And when they've got that timing, they can input that timing measurement onto our website. That will give back to them a personal measurement of the distance from the Earth to the Sun.
Oh, wow. You mean so everyone who observes it can have their own personal measurement?
Absolutely. And we can average them all together and see what sort of answer we get from all the people that do it.
It sounds great. I'm really looking forward to it. Thanks very much indeed. The first transit of Venus known to man in 1639 was observed by only 2 people, Jeremiah Horrocks and his friend William Crabtree. The next pair, in the 18th century, were observed by hundreds of scientists on expeditions to the far-flung reaches of the Earth. The only other transits that have ever been observed were in 1874 and 1882, and they benefited from a piece of technology that was transforming a whole lot of sciences: photography.
Astronomy had come on leaps and bounds since the previous transits, and a new generation of scientists believed that they had the technology to do the job properly this time.
As well as bigger and better telescopes, the astronomers now had photography on their side. For several years before the transit, scientists were experimenting with new instruments like the photoheliograph. But the most ambitious transit device was invented by the French astrophysicist Jules Janssen.
He invented a camera called the photographic revolver. It allowed a series of 48 photographs to be taken in just over a minute. Now, none of the plates he took on the day of the transit has survived, but these are 2 of the original test plates that Janssen took on a transit simulator shortly before the real event. And so these could be the earliest movies ever made.
It was a great idea, but unfortunately for Janssen and all the other observers taking pictures that day, the technology simply wasn't good enough. The images were too blurred to get accurate readings, and even worse, photography didn't get rid of the black drop effect.
So the 1874 transit was yet another disappointment, and the scientific community rather lost interest.
Public interest in the transit of 1882 was just as high as 8 years before. The Royal Society responded by shipping out yet more observers. And across the Atlantic, the American Congress ordered another 8 overseas expeditions, even though most of the scientists thought it was a waste of time.
But there's an interesting twist to this tale. An astronomer called David Peck Todd viewed the 1882 transit from Mount Hamilton in California. He wasn't able to see the entire transit as the sun was too low in the sky, but the bit that he did see, he photographed.
Todd took 147 images in total, but they remained filed away in the observatory until a couple of years ago.
And last year, the plates were turned into a movie.
Next Tuesday will be the first transit since these images were made over 120 years ago. So, for the next few days at least, this remains the best photographic record of a transit of Venus.
By sending out radar pulses from giant radio telescopes, scientists can now measure the distance to the Sun to within a few meters. Amazingly, the 19th century astronomers got to within 500,000 miles of the true figure. One of the prime movers in doing that calculation was the American William Harkness. He also had something to say about our transit. There will be no other transit till the 21st century of our era has dawned upon the Earth, and the June flowers are blooming in 2004. What will be the state of science when the next transit season arrives, God only knows. I'm sure Harkness would be amazed to discover that astronomers can now measure transits not just across the Sun, but across distant stars as well. They're using the information to discover new planets and possibly even signs of alien life. Andy Norton is part of a team doing just that, so I caught up with him again inside the Bristol Planetarium.
We can't see the planet itself, but what we can see is the light from the star. And when the planet passes in front of the star, it will dim the light of the star just by a tiny amount,
But
maybe 1% or less.
You can't measure that.
Yes, we can. We can measure the light from the star that accurately.
The project is called SuperWASP, the Wide Area Search for Planets. These cameras scan the whole sky for winking stars. It's only just started, but Andy reckons SuperWASP could find 50 planets in the first year alone.
When we do find planets around those stars, it'll be good to investigate, if we can, whether there's any signs of life on those planets. Right. And the transiting planets are really very useful for that, because as they pass in front of the star, some of the star's light passes through the atmosphere of the planet, and as it does so, some of it's absorbed by the atoms and molecules in the planet's atmosphere, and so that gives a sort of signature on the light that we can detect, and so figure out maybe what's in the atmosphere of the planet, and whether that shows any signs of life.
Well, that's terrific. Thanks very much indeed. So, don't forget, next Tuesday morning, there's a once-in-a-lifetime chance of watching the planet Venus cross the face of the Sun. Don't miss it. Don't forget to watch us live on BBC One on Tuesday morning. Or you can go to one of the many events that are happening around the country. Full details of them on the website, www.open2.net. where you'll also find instructions on how to observe the transit of Venus.
And Adam Hart-Davies.
Stardate 2004, the 8th of June. We're here at the Royal Observatory at Greenwich to celebrate one of the rarest events in the solar system, a transit of Venus, when the planet Venus slowly crosses the face of the Sun. And you can see it actually happening from our dedicated Stardate telescope in Egypt. The transit will last till about 12:30, so there's plenty of time left